This problem will have multiple student learning objectives. One is to graph equations, in this case the square root of x function, and also find the domain of a radical function. So let's start with the domain of a radical function in interval notation. So what's important is to recognize that the x is the part, the radicand, if you will, inside the radical. The 5 is not inside the radical. If it extended further, then we'd have to worry about the 5 as well. But this is just the x. So for a square root or a fourth root, in fact any radical with an even index, the inside, or the radicand, has to be non-negative. We can express that with an inequality as greater than or equal to 0. And there's nothing to solve because it was just x in the inside. That's it. On a number line, we're talking about a solid dot to the right. So for the interval notation, it would be a bracket, 0, comma, infinity, parenthesis. For the next part, we're going to be graphing this function, square root of x minus 5. In order to do that, we want to plot at least 3 points. Now I'm thinking square roots 0, 1, and 4. I would want to put in numbers that work well with a square root. So if we have the square root of 0 minus 5, that's negative 5. The square root of 1, then minus 5, is negative 4. And the square root of 4, which is 2, minus 5, is negative 3. So we have the point 0, negative 5, 1, negative 4, 4, negative 3. The next one would be 9, and that would be negative 2. And what we're getting is this square root shape. The anchor point, if you will, of the square root shape, the point where it stops being graphed left or right, in this case to the left, it doesn't exist anymore, is when you get a square root and the inside is 0. So you need to find that point. This one was easy to do.